geometry lesson, coordinate proof of using distance with quadrilaterals. In a previous lesson, we did this exactly, proving that the identities of the quadrilateral using the slopes, right? But this time we'll be using distances. It doesn't strictly have to be a distance, but we'll be adding in the distance aspect to that. In the very first question, so we're going to be talking about proving that congruent diagonals is a condition for rectangle, right? You know what? We're going to take that for granted, right? So let's focus on the next two. How do you plan, given this information, to show that ABCD is a rectangle? And then this is a follow-up to this question. How would you show that it is a square? Okay, guys? All right, why don't you go ahead and think about that? All right. All right, guys. I have this writing over here. I wrote out for you ahead of time. Do me a huge favor. You might want to write this small or plan to show the work on the back side of this page. So take care when you do this, okay? So if you want to prove 10.4.4 using strictly slopes, you have to show that it's a parallelogram by showing that the opposite pair of sides are parallel and show that it has one right angle, right? By showing that the adjacent sides, the product of the slope is -1. If you want to do it strictly distance, you either have to show that opposite sides are congruent by using distance formula, or you could use diagonals bisect each other, and you do that by what? Right. If the midpoint of the two diagonals are equal to each other, right? So for example, that one's less intuitive. So let's say you have something like this. Find the midpoint over here, right? So that point is midpoint if it has equal distance between the two endpoints right there, right? So hence that midpoint is bisecting it, right? Right. And then why don't you find the midpoint of the other diagonal? If it turns out the midpoint is exactly the same, it means that this midpoint divides the two diagonals equally in halves. So hence they bisect each other. Hope that makes sense. And in order to show that, so that is to show that this is what? A parallelogram, right? That is just to show that it is a parallelogram right there. But how do you know that it is a rectangle? Well, in most stereotypical parallelogram shape, the length of the diagonals are different. But the rectangle, the opposite sides are parallel, and yet the diagonals are congruent, right? So if the diagonals are congruent, then we know that it is a rectangle. Now, you don't have to do one specific way or the other, right? So what I'm going to do in this case is I'm going to kind of like do a hybrid style. I'm going to show that it's parallelogram by using slopes, but this time I'm going to use diagonals are congruent to finish it off like this. Okay, guys? All right. Let's do it. Let's do it. All right, here we go. So what do? So we have a general shape. We know that it's something like A, B, C, D. So we know that the AB is opposite of CD, right? So let's find the slope of AB, shall we? Slope of AB is, remember, change in y over change in x, right? So that is 4 minus minus 1. See that? 4 minus minus 1 and 2 minus 4. That gives you 5 over 2 negative, right? And you know what? It might be a good idea for you to actually get a rough sense of where the points are. That way, you know if the slope is positive or negative to begin with. So A will be 2, 4, 1, 2, 1, 2, 3, 4. This is rough, guys. It's not going to be exact. 1, 2, 3, 4, going down by 1. That is a B. -1, down 3, 2, 3. It's about here. That's a C. D is -3, up 2, which is about here. So you get a sense that the AB has to have a negative slope. And it's fairly steep. And -2.5 Yep, that seems to make sense, right? All right, let's go with the slope DC, and they appear to be parallel, right? This is an extremely rough sketch. So DC is, remember, it's change in y and change in x. So another way to think about that is y2 minus y1 over x2 minus x1, right? And you have to decide which is the x2 and which is the x1. So I'm going to just like, I don't know, whatever comes easier, right? So I'm going to go right minus the left, the y values here. See that? So that'll be 2 minus minus 3. And then for x values will be negative 3 minus minus 1. So that gives me 5, that's negative. Oh, they're the same. So we know that because they're the same, AB is parallel to DC. So we're good, right? So let's move on to the other opposite pair, which appears to be more positive, but that appears to be like, I don't know, around half-ish, right? All right, so you have to develop these kind of senses, guys. So we got AD. So we are looking for slope between these two values, right? So change in y, change in x. Let's go left minus the right. 4 minus 2. Whatever you do, be consistent. The left is 2 minus minus 3. That is 2/5, right? It is positive. And it's less than 1. It looks to be about half-ish. So that's good. So let's get slope BC, right? And we're talking about these two sides. So let's go left minus the right. That'll be change in y and change in x. Negative 1 minus minus 3 over 4 minus minus 1. So that gives me 2/5. They're the same. So we know that the AD is parallel to BC. That implies arrow, right? Arrow means imply, guys, okay? Maybe I could put that a little bit higher. That implies, this combined statement implies that the ABCD is a parallelogram. So we're good. And I think we agreed that the way we're going to figure this out, because we do have to use the distance formula, right? Clearly, we could see that these two are perpendicular, right? When you multiply it together. But that's not the point of this exercise, right? We are trying to use distance formula. We're trying to mix it in here, right? So we need to show that the diagonals are what? That's right, diagonals are congruent. So now we're looking for the distance here and here. Okay, guys? All right. So what is AC equal to? Well, we have distance formula, right? Which is square root of change in x squared plus change in y squared. Right. So let's look at A and C. Okay, how about these two values? Looking at the x's, we got 2 minus minus 1, which is plus 1 squared, plus 4 minus minus 3, which is 4 plus 3. And that is a 3 and a 7. When you square that, that's 9. When you square that, that's 49. That's 58, right? 58. I would not write down the scratch work over here, guys. If you need some extra space and you like to do it on the test paper, just draw a line and push it off to the side. That'll be 3 squared plus 7 squared is equal to 9 plus 49. That's 58. That's a little scratch work right there, right? Good. And then we have what? The distance BD. Once again, this is square root of change in x squared plus change in y squared. Please utilize the steps that I do, exactly, please. And then we're comparing these two right there. All right. So part of your job is to demonstrate your knowledge. It's not to finish this as quickly as you can. But I can say that these steps right here, you don't have to write that. Okay? I'm writing that portion for the instructional purposes. Okay? All right, guys. So when you take that away, there's a much less writing, right? All right. But be careful. Be careful. There are a lot of numbers flying around here, guys. So BD, I'm looking at these two values, here and here. 4 minus minus 7, which gives me, you still write it down, guys. 4 minus minus 7 plus 3. That's a 7 squared is what? 49? Okay, good. And then let's get the y values, right? BD, right? Y values are here and here. So that would be -1 minus 2, isn't it? -1 minus 2 squared, that's -3 squared, which is what, 9? They add up to 58, root 58. So we know that AC is equal to BD, right? Or they're congruent. Either way is okay with me. So we know that the diagonals are congruent. So if it's a parallelogram whose diagonals are congruent, we could therefore say, ABCD is a rectangle. There you go. All right, guys? Okay, let's go back to the previous question over here. What are we trying to do, guys? We are trying to show that ABCD is a square. How do we plan to do that? Well, we know that we already proved that it's a rectangle. So all we gotta do is show that it is a rhombus. That's right. It is also a rhombus. How? Well, this is one way to do it. We could show that all sides are congruent. And then if we did rectangle by using this right here, opposite sides are congruent, we only have to show that the adjacent sides are congruent. But that is so much work. Is there another way to do this? Yeah, if you think about it. So we need to prove that this is also a square. Okay? So how do you know that it's a square? If you already have a rectangle, how would you show that it's a square? Well, if you look at this shape really carefully, guys. Okay, let me grab this and blow it up a little bit. See this shape right here, guys? That's a rectangle versus a square. Okay, what's similar? Well, we know that the opposite sides are the same, like this, but this all four sides are the same. But beyond that, though, let's get the diagonals. Because square is also rhombus, they're perpendicular. The diagonals, that is, right? Whereas this is not. Clearly, it's not. The stereotypical shape of the rectangle, the diagonals are not perpendicular, right? So that's one way to do it. Okay? All right, guys. So what we're going to do, we're going to make that a tiny bit smaller. Here we go. Okay? So this was intended to be continuous. So using result from 10.4.4, ABCD is a rectangle. Okay, stating that is so much quicker than doing it all over again, right? And now all we have to do is that the diagonals are perpendicular. That's all we gotta do, guys. Okay, so let's get the shape, guys. Shape is that. All right. You know what I need to do? I need to copy down that ABCD. ABCD. So we're looking for the slope of AC. Okay, we're looking for the slope of BD. That's all we're looking for. But you know what we could do, though? This is kind of interesting. Is that, isn't this changing X? This is changing Y? This is changing X and changing Y? The values are very similar, aren't they? Yeah. So this was 3 and 7, which should be 7 over 2. And this is -2. So it's -3 and 7. So slope would be -3 over 7. The negative reciprocal of each other, right? Right. I just want you to make that observation. Okay? See, it's just really important to make that observation. All right, guys. Let me just copy the values over. Actually, you know what? You have your notes, right? So you can see the values. So we know that you know the coordinates of the A, right? The coordinate of the A is 2, 4, and coordinate of the C is -1 and -3. So this is change in Y and change in X is 2 minus 3, and from left to right. And for change, that's change in Y. For change in X, that'll be 2 minus minus 1. Just be consistent which way you're subtracting, guys. Okay, so that's 7 over 3. Okay, so here we got y2 minus y1, x2 minus x1. Guys, I'm writing this out. This step is optional, right? More as a way to show that you could go either way. Okay, you could think about it either way. It's about the same. And b and a d. For the sake of clarity, let me copy down the coordinate of the b, 4, negative 1, and d is negative 3, 2. Okay, so we want to change the y first, and let's go right minus left this time. It's easier. It really doesn't matter, actually. So, you know what? Let's be consistent, left to right. So that would be, changing y would be negative 1 minus 2. Changing x, 4 minus minus 3. That's negative 3 and 7. So we know that the slope of AC times slope of BD, when you multiply it, it gives me negative 1. So that implies, therefore, that the AC is perpendicular to BD. Right? So if it's a rectangle and the diagonals are perpendicular, then we could say that, therefore, ABCD is a square. There you go, guys. All right. All right. So the next question actually is a lot easier. There you go. So it's asking you to do what we just did. It's very, very similar. So I'm going to leave that as an exercise for you guys. Why don't you pause the video, do the best you can, and there you go. Sorry about that. So yeah, if you haven't paused the video yet, you should. I'm just going to work it out without talking too much because it's very similar, right? But to begin though, always just draw some random quadrilateral and say WXYZ because that's the way it's written. And that way we could see that the diagonals are WY and XZ. I want you to draw to get a sense of bearing. So we want the slope of WY and the slope of XZ. And XY is these two. Change by 5 minus 0. Negative 2 minus 5. 5 over negative 7. And XZ is this and this. Change in Y. 5 minus 0. 5 minus minus 2 is 5/7, right? And then the product of these two in order for them to be perpendicular, they have to be negative 1, but it's not equal to negative 1, right? So therefore, diagonals are not perpendicular. There you go. Guys, just because I ask you to prove that I am a Queen of England doesn't mean that I'm a Queen of England, right? So similarly, just because I ask you to prove something is perpendicular doesn't mean that's perpendicular, right? So you either prove the statement is true or prove the statement is not true. Okay? All right, guys. So let's slide down to the next question. It says, question number 14 says, let's analyze, right, the coordinates and sort of figure out what the fourth coordinate should be, right? And if you don't write this out, it could be kind of long, right? So I think drawing something really, really helps you figure this out, okay? All right, guys. Now, in order for it to be rhombus, what do we know has to be true? It has to be parallelogram, but more importantly, it's something that is a rectangle. Sorry. It is a parallelogram, and all four sides are congruent, right? So opposite sides are parallel, and all four sides are equal to each other, okay? Or diagonals are perpendicular as well, okay? All right. So rhombus is a parallelogram with perpendicular diagonals, right? The other way to show that is to, by definition, all four sides are congruent. So depends on what's happening. We may have to go with one or the other, right? So let's draw some rough picture, shall we? It doesn't have to be beautiful, but just roughly proportional. Okay. Okay, I just noticed that this is really crooked. So somewhat straight. Okay. -5 and 5. A should be about here. And B is a 0, 0. C is a 7, which is more than 5. 1. C. That's a B. So it looks like this. It looks like this. So D should be here somewhere, but it should have the same slope as this, right? So it's kind of like that they have to be parallel. So it appears that D should be about here, is XY. Okay. But one of the things I know is that because the slope has to be the same, so in order for something to be parallel, a pair, right? A single pair of opposite side is both congruent and parallel. I think that might be easier to do, right? So let's do this, guys. What is the slope of BC? Right? Change in y, change in x, right? So I'm going to go right minus the left. So change in y is 1 minus 0, 7 minus 1, which is 1/7. But what's really important is that this is change in y and this is change in x. To go from B to C, I want to cross 7 up 1, isn't it? So you could do the same thing. So you could track across 7 and up 1. So I'm going to assume that the D in this case, therefore, is whatever the A is, which is -5, 5. I'm going to add 7, right, to the X value. And then what I'm going to do, add 1 to the Y value, which will give me 2, 6. Now we have to now confirm that that is actually correct. Okay? And that's what we're going to do. Here we go. So before we continue on, what is the length of BC? Oopsie. Let's go back to black. By doing so, the orange really pops out, right? What is the length of BC? It's the square root of change in x and change in y. Oh my gosh, I already have those values, don't I? Yes, I do. So 7 squared plus 1 squared is 49 plus 1 is root 50. All right, guys, so now I have the slope and the length of BC. So now we have to show that, make sure that AD and BC are like that, right? So what is the slope of AD then? Change in y and change in x. So I'm going to write down the x, y and x value of the D, and I'm going to subtract the y and x value of the A, and A is it's 5 over -5. So that's 1/7. Oopsie, slope is exactly the same. And then you know that AD is a what? Change in x squared plus change in y squared. But then again, that is change in y and that is change in x, isn't it? Right, so I could just put it in there, which is root 50. So now I could claim that the ABCD is a parallelogram. If you want to go further, you could say because a pair of opposite sides are parallel and congruent. And that's all we gotta do. But we're not quite done yet because we're actually looking forward to show that this is rhombus, right? So it's a parallelogram whose diagonals are perpendicular, right? Right. Now what you could have done, right? So I'm going to give you an alternative method that you could have done here. that if you had D in this case, and you could have just found distance formula AD, AB, BC, and DC, if you show them they're all the same, then it would have been rhombus, right? But we're not gonna do, but we're doing it this way, okay? So now I have to show that the diagonals are perpendicular. So I have to find the slope of BD. All right, what is BD? Let's make this shrink that just a tiny bit. B is a 0, 0. And what's a D? D is what? 6, 2. So 6 and 2, subtract. And then we're going to subtract the coordinates of the B, which is 0, 0. So that's 6 over 2, which is 3. So that is BD right there. So what is the AD? Sorry, AC. Slope of AC is equal to change in Y and change in X. So the coordinate of the A is Y coordinate is 5, X coordinate is -5. I'm going to subtract the X and Y and X coordinate of the C, which is 1 and 7. Remember, this is change in Y over change in X, right? And that will give me 3 over -12. Did I? Oh, I'm sorry, that's 4. Okay. It didn't look right. So that gives me -1/3. Let's go a little bit further. And we know the slope of BD times slope of AC is equal to 3 times -1/3, which is -1. So that tells me that BD is perpendicular to AC. Therefore, ABCD is a rhombus. Okay, guys? And that is it. This is kind of too big, so I'm going to shrink this just a tiny bit so it'll fit better on my paper. There you go. All right, guys? All right, so that is it. And you have your turn to do. So given these on your notes, pause the video, guys. I'll show you the answer in a second. All right, here we go, guys. These are the answer for the first two. And here are the answer for the next two. All right, guys. I will see you in the next video. Have a good night.